Good morning everyone, or good afternoon depending on where you are. I think it's good morning for WA and Queensland, and good afternoon for the rest of the country. Today we're going to be taking a look at some more of the new features of Solid Edge ST5. These are just today we'll be looking at a collection of small things that can make some quite big productivity gains for you. As always, you have a little question box in which you can type your questions. I have disabled the microphones from users, otherwise because I just can't keep up with the number of questions. There's too many people online. And so if you've got any questions, type them in there. If you could hold them to the end, that'd be good, but if something goes wrong in the middle, let me know. Okay, let's make a start. What's ST5? More of what's new. We'll be looking at some frame and piping enhancements. Some work that's been done in the engineering reference area, especially in gears. Take a very quick look at that. Some of the geometry fix-up tools. Geometry Inspector, which we've always had, has been optimized, has been worked on, and we've got a new geometry optimized tool which we'll take a look at. The other area we're looking at is large layout sketches. These are imported DWG DXF drawings that can become very unwieldy, very large ones. We've got some tools to clean those up, and we'll take a look at that. There's a new user interface for View and Markup and Revision Manager. We'll take a very quick look at that. And a new feature for ST5 is the ability to import very large terrain models. Now, these are some of these can be very large indeed, and we'll take a look at that. And then finally I'll just have a quick talk about the Solid Edge mobile viewer that's available with ST5. So framing and piping, let's have a look at what's happening here. When we're doing edits on XpresRout runs, either in framing, if you don't have XpresRout, the center lines, editing those is very straightforward, but it's been difficult in the past for people to see exactly what they're editing. The edit spheres that are highlighted are quite small and have been, in some cases, difficult to pick up. So you'll find that's vastly improved. The other area that's another area that's been worked on is the quick edit. So if you select a pipe or a frame or a wire, from wherever, so you don't have to be in the framing mode, you don't have to be in XpresRout or wire harness. The edit tool will appear on the screen. It's a pic of it here. So you can, here we've selected a frame. We can change the end condition, we can edit the cross sections, or we can do a full edit definition. You don't have to be in the framing mode to get to that. It'll switch you into the right mode. And there's been a lot of work done on the extend and trim option. It's quite new and solves some unique issues that you may have, and we'll take a closer look at that. So let's switch over to Solid Edge and take a look. Firstly, I'm going to look at this little wire harness in here. So we just open up the wire harness, open up the wires, and just pick any of the wires. So I'll pick a wire here. This one for edit. I'm in XpresRout. My apologies. I've been having a fiddle with that just a few minutes ago. Shouldn't have done that. We see the edit tool come up. I click on the edit, and you see the key points on that wire appear, and they're nice big round red balls. Very, very simple. So you can edit those quite easily. If we go into the pipe, if I just select a pipe here and select the edit pipe tool, it'll take a second or two for it to open the database. But what we'll see here is it will highlight the ends of the runs with the red dots, and it's highlighted the pipe that I selected, but you can see the ends of the runs with the red dots here. And as it gets the database open, what we'll see is the ability to replace the pipe segments here. but these red dots are always visible through the geometry, no matter how much geometry is sitting on top of them or around them. They appear on top all the time. So very useful for editing. As you saw in the wires, they stand out. They're easy to pick, and pretty fast to get hold of. This database is taking a second or two just to come open. I don't think I had the standard parts open, which is probably why that's taking a little while. There we go. So we've got our piping attributes come up here, and I could change that pipe type or diameter or whatever I need to do from here. Likewise, if we select a fitting, I'll get the just cancel out of that for the moment, close out of XpresRout. So just working on from the top level, pick the fitting. I can edit the whole definition, or I can just edit the fitting itself, which is what I'm going to do. So I pick that fitting, it'll open the database on that for me, and I can make a decision as to what I'm going to do with that fitting. So I could say I want to rotate it, do whatever I want here, or replace the fitting. So just clicking on that icon will open the standard parts, and I'll be able to select a different fitting or a different size fitting from right within there. I'll just cancel out of that because that's not really what I want to do. Again, working from the top level, we'll notice we've got a miter corner in here. I want to change the corner treatment. I just click on the frame member, select edit corner conditions here, and there we go. So we've got the two green dots at the end, and I can determine which end I want to access. So if I say I just want to, I'll deselect those. I want to select just that end, and edit and check that off, and change the end condition to a but. We'll see it changes to a but or to that but. So I'm just changing that end condition there. If I'd selected both, I could have selected both end conditions. There's another option I can work on in here. So let's just take a look at a different frame. Here I've got a frame with some other geometry in here, and I want to trim these frame members back to that geometry. So if I select, here's my frame 1, if I select frame 1 and say I want to work with the end conditions, cancel out of that, and I want to work with the end conditions, you'll notice that it's got red dots come up on each of the corners of that frame. This is the corner that I want to edit, so select that, and I want to do an extend or trim. Now, when I selected the extend or trim command, it automatically selected, using the auto select here, the two frame components that met in there. If I turn that off, I could do that manually, but that's fine. Down on the bottom, it's prompting me to a plane, a face, or a body to trim to, and I'm just going to select that surface that I've got in there, and we trim back to that surface. So as you know, the surface doesn't come out in the drawings, but we will trim back to that, which is what we want. It'll just trim back to there. Likewise, if I'm working in this frame again, it's frame 1, end conditions, and I want to pick up the end conditions again, and it's this end condition here I want to edit, select that off, and a trim again, and again it's selected both of those. If I turn that off, you'd see it, I could select that one, or I could select the other one. If I turn it on, it'll select both. And I want to use the outer rim of there to trim. Finally, I'll finish that, and I want to pick up this frame 2 in here, pick up the end conditions there, and again just pick up this end here that I want to trim, and alright, trim extend, use my feature there to trim to. Now I've got a common situation that many of you have probably come across at one time or another, where you've not been able to trim beyond the end of a line. Let me illustrate what I mean by that. I've got a round tubing I'm going to put on here, just a 1-inch tube, 25mm tube. Accept that, and you see how that tube has trimmed but it only goes as far as the end of the line. It's trimmed where it's met this member, but it won't trim beyond the end of that line. That line is touching the outer edge of the frame here. It won't go beyond that. So this allows me to do that trim. So I can pick up that end that I want to trim, select that off, do the trim extend, and select the plane or body that I want to trim to. And I just selected that body and it's trimmed. That happened fairly quickly. So we'll just do that again so you can see it. It creates the member. If I exit out of that and just select the member and say I want to change the end conditions, you notice got both end conditions selected. I only want this end condition, so we'll accept that. I want to do a trim, and I want to trim to that member, so you'll see that. I'll leave it for a second so you can see it highlight, and it trims to it. And we've got a perfect trim there. So just gives you an idea of what we're doing here. Okay, back to our slides. I think you'll find this these options very useful. There's a couple of things with fixing up imported geometry. Geometry Inspector, which we've had for a long time, now fixes a great deal more faults, and it'll actually fix them from within the Geometry Inspector. It actually gives you a lot of information. It'll tell you how to go about fixing it, but it'll fix it automatically for us by clicking on the Heal Body Faults button. We'll have a look at that in a second. There's a new function called Optimize. If you look in your edge bar when you've imported something, here's a part copy, just an imported part. There's nothing clever about that. But you'll see this little, next to it there's a little, gee, what's that thing called? It's called this thing here. Just a little information area. Just highlight that for you. You'll see that if you hover over the item, you'll see the quality of this body may be improved. That's because a lot of non-parasolid bodies that we import mightn't be as accurate as we would like, or as Parasolid needs. Parasolid's very picky about having manifold models, so you might find some edges that don't lie accurately along your face boundaries. You might have some B-spline faces that appear to be blends but are not quite blends because they don't quite fit. Those types of things, and this is what Optimize will fix up. So let's have a look first of all at the Geometry Inspector. And we're in the Inspect menu. We see Geometry Inspector. Here's our Optimize right below that. So Geometry Inspector, it'll inspect the active models. There's only one there, so we hit the Go button, and it says there's 3 faults found down here. Let's open those up, and there's 3 faces that are self-intersecting, and then we'll just click on those and you'll see them highlight in orange on the model. And it says down here, clicking the Heal Body, which is this button here, will attempt to repair the faults. You may have dependent features which need to be rolled back, etc. So a list of instructions there and things to do. If you see this little icon, which is a let me just show that up for you. If I can find my my little highlighter, it's disappeared off the bottom of my screen here. But you see a coloured little indicator in the middle of that screen. It will show if there's any dependencies on that body, and by dependencies we mean associative links and things like that, and it won't fix those because you have to break the links first. Okay, let's just heal the body faults. You'll see that's quite quick, and the faults have gone away. If I do the Inspect again, it's all good, so you don't see it again. Okay, let's try a different one, the different fault. This one, if we look at it carefully, behind these behind these ribs here, there's sort of no body in behind a fillet here that's sort of hanging out in space. It's sort of a bit strange. Okay, so if we go to Geometry Inspector, hit the Go button, it will tell us about there's 2 faults found, and it says 2 vertices don't lie on the edge of a curve, so it can't actually fill those bodies in, and if I highlight those, you'll see the 2 edges. So again, if I say heal the body faults, it fixes up those edges, and now we've got faces behind those ribs which weren't there before. One more is this one's a nice molded shape of some description. We'll see that. Okay, what we want to do is have a look at that. Do in Geometry Inspector. Geometry Inspector is very quick, worth running. It says there's 1 fault found, and it says fillet in here doesn't quite make it. So again, if we heal that, it's fixed. So now we've got a much more robust and reliable body. Okay, that's, as I said, we're talking about the Geometry Inspector there. But let's have a look at the Optimize. If we come back to our I'm bringing a new part. If we just look at our edge bar here, it's a part copy there. If I hover over the little information button, that should come. That will that it probably takes a while to come up on your screen because of the internet connection speed. However, that needs to be optimized. The little information button there says optimize. So we take our optimize command, a toolbar comes up, and down in the prompt bar it says click on a body to optimize. So that's our imported body. We have a dialog box for options, and it'll clean the body and do a full body optimization and create a report. So we'll just say OK to that. This icon here says emphasize faces and edges. What that does, when I click it, you'll see in red a whole group of little faces that get emphasized and shown up. They're the faces that aren't quite working properly. These B-spline faces that are trying to be fillets and they aren't quite making it. All I have to do is hit the finish. It'll give me a report, and it's fixed it. So if I just hit the optimize again, hit it again and show the edges, it's all done. Okay, let's try a different one. This one's a little more complex, and it has a different fault on it. So again, let's just try the optimize. I'll leave everything at default and pick up the edges that it wants. And you see there's a lot in here, and there's a lot of, again, fillet faces and things that aren't quite making it. So let's do a finish. And it's processing this. There's a bit more to process in this one, so it'll take it a little bit longer. But what we'll see in the report is some of the work it's done, and we'll be left with, I think this one leaves us with 1 more fault that we can manually fix, so I'll show you that. Okay, it's saying part body before and after, face count, cylinders and so on. As a total 357, there's 356, so it's actually removed. Some of them it's actually B surfaces. It's turned into blends. There's 148 B surfaces, made 147 blends. So there's still 1 of these B surface blends that didn't work properly. The edge counts, lines, etc. at 809, 807 at the end of the process. If we just finish this off, hit the optimize again and find out what didn't work. What we see is this little fillet in here didn't work, so I'm just going to cancel out of that. I don't want to do it again. I'm going to go to home, get out of this, pick that face and delete it. Now just check this fillet here, because I put a fillet in there. It's a 5.1 fillet, so we do a round, pick that edge, 5.1. I've done this before just to make sure it works, and I've replaced that fillet, and now it's all good. So we've actually fixed up this model. These are very powerful tools if you're handling imported geometry. You can clean up a lot of errors. Okay, moving on. Large layouts. Now, what we're talking about here is things that are typically imported from AutoCAD. You might have a big layout drawing that you want to work with that's come from DWG or DXF. But when you bring it in, some of them get pretty clunky in the way you can work with them. Opening times are very slow. Doing anything with them slow and painful. A lot of these issues arise from things like you've got a huge number of redundant points in the file. You've got duplicate geometry, lines on top of lines, those things. Things that are poorly constructed. A lot of identical elements. You've got a lot of what we call self-intersects, and duplicate control points where we've got more redundant information in the system. And then you might have very, very tiny line or arc segments. These things are hundreds or even thousandths of a millimeter in size. They're just very, very tiny. How they get there, I don't know, but we need to process all this stuff and clean it up. So we've got in all the sketch environments now a thing called Clean Sketch, and that does what it says it does. It cleans up this imported. Once you're in Solid Edge, once you've got it in Solid Edge Draft, it cleans up these imported layout sketches, drawings, call them what you will. Just to give you some idea, some of the performance gains. These are opening times. Contrived. Contrived means it's one that Siemens created. 8,800 elements in there. In ST4, used to take us 6 minutes and 30 seconds to open. In ST5, it's 2 seconds. Some customer examples: 68,000 and 50,000 elements. This one took nearly just over an hour to open. Took 45 seconds. This one took just on an hour to open, and again 30 seconds. So huge performance gains. These process drawing data and blocks as well, so it doesn't just deal with just the drawing data. Here's an imported AutoCAD document. I don't have any large ones here, but just clicking on some of these elements gives you an idea of levels of complexity. And if we care to zoom in on these, what we'll see is lots of duplicate elements and those sorts of things, and things where it could be arcs and lines aren't. So I'm in the draft mode or in a sketching mode, and we see here Clean Sketch. It's in the Draw command bar. I click on Clean Sketch. Let's have a look at what's in the dialog box. Clean B-spline curves. It'll do. We can turn on or off that. We're going to delete elements, but instead of deleting elements, we could move them to a layer, and it will delete identical elements, redundant point elements, and arc and line segments that are less than this particular size. So by changing that size, I might change that to a larger number, and I'd get rid of small segments. I might want to leave it with a lot of the small segments for these flowing type things here. Okay, so all we have to do is, as I said, select it and finish, and it's that quick. And we see that we've simplified a lot of these things, and if we go and examine them, we've not got intersecting points and those sorts of things. So we haven't lost any of the shape at all, but we've simplified it. We've turned it into solid edge geometry, if you like. Let's have a look at another one. Bit of a layout sketch here. I think these are hotel rooms, aren't they? Something like that. But if I zoom in here, and this is very typical, if I just hover over a line, Quick Pick will show me that I've got lines and lines and lines on top of lines. It's pretty horrible, actually. And I can go through here and I've got better or worse ones all over the place. Some of them I've actually got those large numbers of lines on top of lines. This one here, yep, lines on top of lines. And there's other geometry faults in here. Again, we go to our sketch, pick up the Clean Sketch tool, using the same defaults as we had before, click Finish. It's that fast. Now when we go to those lines, hover over a line, no dots from Quick Pick, so I've cleaned that one up. This is a very powerful tool. I think this will, for people who are dealing with imported sketch geometry or drawing geometry, this will be a godsend. There's no doubt about that. Okay, moving on. We're We're doing well. I don't want to use up too much of your time today, so let's move along. View and Markup and Revision Manager has the new fluent user interface. Whilst there's some very, very tiny revisions, there's nothing major change. It still works the same way, but you'll see in Markup here we've got an icon for cross sections and so on. So it's there's a the cross sections in View and Markup. What we want to do too is note the position of the Perform Actions tool. That's over here now. Instead of being hidden up on the toolbar under Save and things like that, the Perform Actions is right there. Let's just take a very quick look at that. I've got it running here somewhere. He says. I'll just have a look at Revision Manager. That'll do. Just open something. Oh yes, I'll bring in something with thousands of parts in it. That's typical. And it's out on my server. That's very useful. But we've got our preview, those sorts of things, and all the same sorts of things. So I want to expand everything like we did in the past, but the icon's right here. I want to select all the files. Let's say we want to just rename everything in there. That all happens, and now our Perform Actions button comes live. Until I've got something, some actions to carry out, it's not there. So Perform Actions right in the middle where you can see it. We can clear actions, of course, and that just undoes everything that I did. So not a lot of changes, but it's just cleaned up the user interface to make it consistent with the rest of Solid Edge. We're just catching up. So it's got the fluent user interface. One of the big changes for this version is the ability to be able to handle what we call terrain models. Now, I need to give you a little bit of background here. If we're looking at a parasolid file, a parasolid modeler, it has some restrictions on size. We know that it produces extremely precise models, but this is sort of goes against the grain if we're dealing with terrain models. Now, by terrain models, I mean whole sites. These might be building sites. These might be sites on which people are creating mines, buildings, what have you. We're dealing with many, many kilometers, not just meters, it's kilometers, thousands upon thousands of meters in size. So we get some very large parts. Now, the maximum size of a parasolid part has to fit into a 1 kilometer cube. Now, that sounds a bit strange, but that's how it works. It has to fit into a 1 kilometer, not cube, sphere, which is much less than a kilometer cubed. So let's have a look at a workflow here. What we'd do is, in the resource industries, is we'd get survey data in the form of an STL file. Now, those of you who dealt with stereolithography files know that they're just bags of triangles. We can't actually do anything with them. So we need to be able to convert this data into solid edge parts so that we can work with it, we can measure it and do those sorts of things. We need to break those up into less than these 1 kilometer spheres to be able to deal with them. And we can do that inside an assembly. We can break these things up into individual parts. They're all put together in an assembly. We can deal with them as a single entity. So we then publish those terrain models. Now, what that publish process does is it drapes the STL file, your stereolithography file, which I said is just a set of triangles, over a solid. And it does effectively a replace face. It's not a replace face function as we know it, but it uses a drape function, and we produce a surface on that solid which exactly matches the original STL model, the triangle model. We'd use it for modelling earthworks, doing cut fill calculations, those sorts of things, working out exactly the heights of where conveyors are going to go and all of those sorts of things. Very powerful for people in the resources industry. Let's take a look. So switch back to Solid Edge, close out of that. Okay, let's take a look at how this works, this terrain modelling. I've opened an assembly here that's got a part file in it that has a converted STL file, stereolithography file. If we just highlight that and zoom in a little bit, what you'll see in there is just a set of triangles. It's not a solid model. It's way too big to be a parasolid model, and in general STL files, we can't do much with them in Solid Edge. We need to make them into a solid, and this will automate that process. The first thing I do is I create a couple of virtual assemblies to contain this information. So I make an assembly called Area 1, and I'll make another one called Area 2. Now in those sub-assemblies I need to put a virtual part. So I'll call the first one P1. We're going to have really original names. P1, and in here I want to put P2. So you see I've got a structure here that's got my top level assembly. There's my terrain.par, which is my converted STL file, and then I've got a virtual assembly, another virtual assembly, a virtual part, and a virtual part. We say OK to that. Now what we need to do is to go to this sketch here, which I'll explain in a second. What we'll see is I've got a sketch here that's starting to break up this large model into the smaller segments. Now, as I said before, to be safe, we've made our maximum circular area 700 meters, and if we work it out, about 495 on each side of a box is what will fit inside that circle. So I've got several of these 495 boxes ready to start breaking this up. I've only created 2 sub-assemblies for this and 2 parts for this, so I'll only do 2 of them, but we can do as many as we like or as few as we like, and the boxes don't have to be connected either. They don't have to be 495, they can be smaller than that, but the maximum they can be is 495. So let's assign the geometry to one of these virtual assemblies. So I'm going to right click on it and say edit its definition, and I'm just going to pick off the sketch information here. So just pick off the lines. We accept that. Now it's prompting for us for the origin of the sketch, which will be there, and its x-axis positive direction, which will be there. And I finish. Right, and we'll see on the glyph here on the edge bar, there's information now in that area 1. Do the same for area 2. Right click, edit definition, and pick up the edges of the defining box. These are again 495. Tick that off. I want the origin and I want the x-axis direction, and finish. We can close our sketch at this point, finish out of the sketch edit, and close the sketches. We don't have to see the sketches. So what we have now is 2 virtual assemblies with parts in them, and we need to populate those parts. So to do that we need to publish them, and we've got this publish terrain model. Now as we saw from the previous slide, we set a maximum height restriction of 500. Now that's coming up from my sketch plane, which was on my XYZ, and my little island here is sort of in space somewhere. We can manipulate those to suit what we're doing, but I'm just going to bring that up, say 300 will do. Now it's telling me what it's going to do. It's going to create those files, area 1, which is an assembly, and it's going to place it in this folder, and it's going to use the assembly and part templates, and all I have to do is hit publish. You see my little timer goes off there, and if you actually watch in the file you'll see those parts being created. Now it's done. It's that quick. So you saw the little timer going on the cursor, and it's produced those 2 models, which is all I asked it to do. Let me turn off the terrain, and we can look at the. Let's just go back, go down to that part, and we'll in-place edit on that part, and we can see it's a part file. Now I can use sketches on there to cut things away and do calculations on the amount of material I remove or add or whatever I want to do. So I can start modeling on that. One of the things that that we have with ST5 is a mobile viewer. The the idea behind the mobile viewer is it allows you to carry very large and complex models out into the field. It works on the iPad at this stage. It's a free download from the App Store. It'll take all model files, part sheet metal, assembly, and so on. You can hide and display different things out of your product structure tree. So you can hide subassemblies, show subassemblies, hide and show different parts. If there's PMI information on the models, you can optionally display that as well. Quite large assemblies come down to quite small sizes. There's an application in ST5 to create the models ready for the mobile viewer, and it sends them. It just sends them out, so it's ready to. They're ready to view. There's one more thing I'm not sure if we covered in here. The engineering reference tools with gears. I didn't take a look at that, so we'll just very quickly pick that up, and I'll show you what I was going to be talking about. With our engineering reference tool, when we create gears, in the past it just placed the gears for us. So if we made a gear set in the engineering reference, it produced the two spur gears, as in this case, but there was no assembly relationships. What we'll see now is that there is a gear relationship, and it's placed assembly relationships on them such that they will actually run. So if I just turn on my simulation and hit the play, that'll update fairly slowly on your screen, but they will actually run. So we've improved the assembly constraints that are built in there, and built proper tools on them. We can see the same with a spiral bevel gear. Again, we've got relationships on those, and we'll see that we've got a gear relationship on them such that we can simulate a motor attached to the driving gear, and they will do their thing, which you'll see happen in the movie. Okay, back to the summary or aspect of it there. Okay, mobile viewer, it's free. The questions, I know there's a lot of people going to be asking the questions, is it available for the other types of pads yet? Not yet. It's probably some time off yet, because there's slight graphics differences with the different manufacturers of the other types of pads, and there's more to cover. But I understand Siemens are actively developing for the other pads, but right now it's iPad. So there's a lot of things been included in ST5, as you're no doubt aware. It's worth trying out some of these things for yourself, see what'll fit for you, what'll work for you. It's again, like everything else, start small and work up to being big, and it's probably going to take a little time to get used to some of these things. There's, as usual, all the resources, more clinics. Let us know what you'd like in the clinics. So if you want another clinic on any part of this, or any combination of these things, let me know. And of course there's always the normal help resources out there. So it just remains me to thank you for your attendance. See you again in about 2 weeks' time. Next week you'll get an email about what the next one's about, and I look forward to seeing you all then. Thank you very much.